Okay, greetings one and all, and welcome to this has to be day number 2. Yes, day number 2, week 10. Day number 2, week 10, spring 2025 of our journey together, and it's definitely a delight. It's certainly a delight to have each and every one of you here for this evening's classes. Let's begin. So let's head up. Make sure I write this information in your book. My name is Mr. Petit. E-E-T-I-T. Today is Tuesday the 11th of March, 2025. The subject is, of course, mathematics. All right, and today we're going to be looking at topic is, we have to finish off sets. So we started that off yesterday. So we're going to be looking at sets. We're going to do a little bit of mensuration. And then what else we could do? And then we could do, yeah, sets, mensuration, and we might get into probability if we have enough time. We could do probability. I can't wait for probability. That's what I actually want to do. But if we have enough time, we could get into probability. Okay? Go ahead.
Are we having the red on right now? So I could just put it on my computer for now, please.
Yes, you can. No problem. This is let me put this in green. So with the sets question, we're gonna continue from where we left off yesterday, and then we're gonna build from that because we didn't finish the question. All right. Class, have you all written this down as yet? Let me know, please, before I move this. Let me know, please, if y'all have this written down.
Good night.
Good night. Good night. Good night. Have you written this down as yet? Let me know, please, before I move on.
No, sir.
No,
Yes, sir.
still writing. Okay. Good evening. Good evening. Good evening. Okay, so let's finish up with sets. If I ask you the question, can you also let me clearly? Let me know, please.
Yes, sir.
Okay. Y'all sure you can still hear me? Wait, 1 second. Let's try it now. Can you also let me clearly?
Yes, sir.
Okay, good.
Better.
Much better. Okay. All right. So let's say that. Oh, let me open the thing. So let me give you all the symbols. Let's say if we have this, what is this a symbol of? We call that. That's gonna be the what? Y'all know what a symbol this is?
Universal.
What is this?
I don't know what that is. That looks a bit strange.
The set.
What it is?
Universal?
No, not the set itself, but it's the bracket of the set. Universal set.
Universal.
Bracket.
Oh, that's what that is. Yeah, I know. What that is.
Universal set. Universal set. Max. What if we have let's say we have maybe this. Let's say we have this. What is that?
Union.
Union.
That's the union. It's the union. Union of sets. What if we have, say, this?
Intersection.
Intersection.
Intersection. Very good. We're going to, let me put this here. It's going to be the intersection. Intersection of sets. Let's say we have let's say we have let's say we have this union, intersection, universal set. Let's say we have this. That's gonna be the what? What is this called? Um,
Less than or equal to?
no. We call the subset.
Oh.
Subset. You all ever heard of that? Subset.
Yes, sir.
And then we have so we have the universal set, we have the union of set, we have the intersection of set, then we have the subset. What do we have? This one.
Complement of A.
Who said that?
Mia.
Amia, very good. It's called a complement. Okay, let me unmute. Some of you might want to speak. We call this a complement, okay? Or the complement of A. All right, it's a complement. So it's going to be a complement. A complement. So basically, let's go ahead and explain what each of these means, right? The universal set is going to be the set. It's like the mother of all sets. It's going to be the set from which all of the other sets that are in the question come from, okay?
It's gonna be all numbers put together.
Yeah, it's going to be, this is going to be the set from which all other sets in the question originates from, okay? The mother set, right? Then you have the union of two sets. That's basically when we join all of the sets together, but no repeat with the union. And then we have intersection of sets, and intersection of sets is going to be when we all of the elements that are in common, right, in both sets, that is going to be a part of your intersection. And then the subset is a set within the set, right? So if we have like a set, so let's say we have this set, say we have this set, right? We call this set A, right? If we have a set, another set inside, if we have another set inside of A called the set B, right? We say that B is a subset of A because B is inside of A. Does that make sense to y'all? Let me know that. Let me know if that makes sense to you.
Can you start one more time, please?
So B is a subset of A, which means that B is inside of A. So a subset is a set within a set. Okay, that's what we mean by a subset. Does that make sense? That makes sense. Yeah. Yeah. And then a complement is going to be everything inside of A. Sorry, everything in the universal set except for A. All right. So we do not include A, but we include everything else. Okay.
Mr. Petit,
Uh-huh.
what is A?
A is a set. A is a set. So it
So
could
they
be,
would tell us what A is.
yeah, they'll tell you what A is, right? And whatever
Yes, sir.
whatever elements inside A you do not include. Okay. So do you have this written down before I move this? Because I really want to move this so we can move on to our next question.
Yes, sir.
Okay, good. So
Excuse me, Mr. Petit, what about B complement?
B complement is the same thing. We do not include B. All right, so let's go ahead and write this question down. So let me erase all of this. We're gonna start from A and then go to B. I think we already answered.
Can you let me get a screenshot of it, please?
Oh, sorry, I already deleted it. I'm sorry. So what are the natural numbers? Natural numbers are gonna start from what? Natural numbers start from what?
1,
1, very good. So what are the natural numbers that are less than 12? It's gonna
1,
be-
2,
So it's gonna be 1. What else?
2,
2,
3,
1 through 9,
3, 4, 5,
5,
3,
6,
4,
7, 8, 9, 10, 11, 12,
yeah,
5,
11,
4, 5,
6,
6, yeah, 6,
7,
7,
8,
8,
9,
7, 8,
9,
9,
10,
10,
Excuse me, Mr.
and
Petit.
11.
10, and 11. Yes,
Are we writing this down?
yes, write this down for me. It's just a continuation from yesterday. And then multiples of 3. What are the multiples of 3?
3, 6.
3,
Now,
6,
the multiples of 3, they have to be less than what?
9.
12,
Less than 12.
3, 6, and
3,
9.
6, 9.
Okay. All right, they have to be less than 12. Okay. Now, there are multiples of 9 that are greater than 12, but remember, the other sets are going to be subsets of the universal set. So that means that we cannot go over 12. So it's going to be what? Multiples of 3 are going to be what? 3. What else? 6.
3,
And what
6,
else?
and 9.
3,
9.
6, and 9. Very good. Why do we stop at 9?
Because the next number after 9 will be 12, and it has to be less than 12.
Very good. Based on the criteria given to us by the universal
Universal set.
set. And then what is Q? Q is going to be what?
Even numbers less than 10.
Less than 10.
I mean 12, 12, 12, 12, 12.
Okay, okay.
Multiples
Or we could
Multiples of two?
just say multiples of 2, right? All right, multiples of 2. Multiples of 2. We don't have to say less than 12 because we already have the universal set, but tells us it has to be less than 12. You understand that? So multiples of what? Of 2.
2.
Or you could say even numbers. Okay. Okay, so now we have everything together. Go ahead, Crimson, read part A. What does part A tell us to do?
List the members of set P.
List the members or list the elements of set P. And what are the elements of set P?
3, 6, and 9.
3, 6, and 9. Very good. Remember, P is going to be the multiples of 3. And so we already have it. We already have the curly brackets inside the question. So we're just gonna put the numbers there. 3, 6, and 9. Okay, 3, 6, and 9. Aiden Gray, do you understand this? Let me know if you understand this, Aiden.
I do. I did this before.
Perfect. Aiden Adderley, how about you? Do you understand this? Aiden Adderley.
Sure.
Good. Ajani, what are the multiples of, sorry, what are the elements of P? Ajani, what are the elements of P? Ajani, what are the elements of P?
3, 6, and 9.
Why is it 3, 6, and 9, Ajani? Why is it 3, 6, and 9? Go ahead, Ajani. Why is it 3, 6, and 9? Because what? Class, tell us why is it 3, 6, and 9? I don't know if you could hear me.
Because they are the multiples of 3 and less than 12.
Very good. They are the multiples of 3. Good. All right. Do you all have this written down? Before I move the slide, let me know, please, because I want to move this.
Yes, sir.
Yes, sir.
Okay, good. So let's go ahead and move this. Good. Travanti? Where's
Yes.
Travanti? I see hand raised. You have a question or something?
Bye-bye.
Okay.
I miss you.
Anyone have a question on this? I think this is straightforward, but does anyone have a question on this? How we got it and stuff? Any questions
No.
on that? We good? All right. So moving right along, we're gonna do it like this. Okay, so take a picture of this and send it to me via WhatsApp. I need everyone to do that for me right now. Take a picture of this and send it to me via WhatsApp. Let's move on to the next question. Again, take a picture of this and send it to me via WhatsApp. I got that P is equal to 3, 6, and 9. Okay, so I got. Again, take a picture of your work and send it to me via WhatsApp. Now the next question.
So, Mr. Petit, quick question. So we actually have to list all those what they asked for, right?
Yes, you have to list them, and it's gonna be very important. especially for what we're gonna do now, because for part B, right? For part B, they want us to use the diagram below to fill in the given information, okay? And so what I did was, and I want you to do it the same thing as well. What do we call this? This. What do we call this?
Venn diagram.
Venn diagram.
Venn diagram. Good. And what is this?
Universal.
Universal set. So we have to use the Venn diagram to fill in information, right? So how are we gonna do this, right? So remember we said from the beginning, we know what the universal set, right? The universal set contains all of these elements, these numbers 1, 2, 3, 4, 5, 6, 7. Please draw the Venn diagram. Again, please draw the Venn diagram. 8, 9, 10, 11, and what else? And 12, right? Okay, that is the universal set. Then we know that P is going to be, P is the multiples of 3. It's going to be 3, 6, and 9. Okay. And Q is going to be multiples of 2 or even numbers. So it's going to be 2, 2, 4, 6, 8, and 10. Okay. Good. So how are we going to fill this out? Some of you may know, some of you may not know. For those of you who know how to do it, let me know. How are we going to fill this out, class?
I know.
Yes, you have to draw it. You do have to draw this diagram.
P equals
How are we going to fill?
P
How are we gonna
equals 3, 6, and 9. So you put 3, 6, and 9 in P.
Okay. Let's bring back memories of what?
We did do this on the first day.
You was there for the first day? Wow,
Yes, sir.
that's insane.
This bring back memories of English.
Of English. Oh, yes, that is
I
true.
know. I think I have a good idea on how to do it.
Go ahead, Amaya.
Okay, so for P,
Uh-huh.
you would only put what's in P, but what's shared between P and Q, you put in the intersection part.
Very
And then you
good.
fill a Q, and whatever's remaining can go on the outside in the universal part.
Very good. So let's do that. Let's do the ones that are common. So what is common between P and Q?
6.
6.
6.
Next. Is there anything else that's common between?
No, sir.
No, sir.
So 6 is the only thing that's common?
Yes, sir.
Yes, sir.
Okay, so it's gonna be 6. Okay. And then P. What else is a part of P?
3 and 9.
3 and 9. Very good. And then, oh, I need to do the 9 better than that. And then we have 9 here. Okay. Those are the elements of P. Now we need the elements of
Q.
What are the elements of Q?
2, 4, 8, and 10.
That's gonna be 2, 4,
8,
8,
and 10.
and 10. Very good. 2, 4, 8, and 10. Remember, what's common in between them is going to be
In the intersection.
an intersection, so it's gonna be 6. And so now we're finished, right? We're complete. We're
No,
good.
sir.
We don't have nothing else to
No,
do.
sir.
No, sir.
No, sir.
What you mean no?
You put the set on that or in the there. Universal set on the outside. Like
What do you mean by that? So I already have 3, 6, and 9. I have 2, 4, and 8, and 10. What else am I
Get
gonna
the
do?
rest of
I have to do what?
You have to put the rest of the numbers on the outer part.
I have to put the rest of the numbers on the outside, right? Outside of the circles, but inside of the rectangle.
Box.
So, okay, so I'm gonna eliminate all the numbers that are part of the union. So 3 goes. We don't need that. By the way, let me use a different color so y'all could see it.
Oh, you
So,
skip 2 and go.
I'll just go on with P first. So 3 is no longer there. 6 is no longer there. 9 is no longer there. How about Q? Q is gonna be 2 is no longer there. 4 is no longer there. 6 is no longer there. 8 is no longer there, and 10. So what are the numbers that goes on the outside? What are the numbers that
1,
goes on the
5,
outside?
1, 5, and 7.
Say it again.
1, 5, and 7.
1, 5,
1,
7, 11.
1. What else? 5. What else?
7.
7.
11.
11.
11. Wait, is 12 a part of the universal set?
No, sir.
No, sir.
So
Because it's number less than 12.
It's a less than 12, so it's not okay. So 12 is not even supposed to be a part of that. So let's move this. By the way, that was a trick question. I knew that was not supposed to be a part of that. I wanted to see if y'all would catch on. No. Yeah.
I have my eyes on you, and I know that you trying to trick us.
All right. If you say so. All right. So what we're gonna have on this outside, it's gonna be what?
1, 5, 7, and 11.
1, 5,
7,
7,
11.
and 11. Okay. 1, 5, 7, and 11. Okay. I think we're good.
The food store?
Yeah, good. Because and the way you know that everything is good, you have to count. So let's see if when we count, if everything has a part of it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good.
And 11.
And 11. Very good. All right. So do y'all understand how I fill up my Venn diagram? Y'all understand that? Does that make sense to y'all?
Yes, sir.
Let me know if that makes sense to y'all.
Yes, sir.
Okay. Waterfall, do you understand how we got this? There's waterfall.
Yes, I understand.
And Danielle Johnson, do you understand how we got this? Or no?
No, sir, I just joined, you see, so.
Oh, you just joined. And Courtney McKenzie, where's Courtney McKenzie? Where's Courtney McKenzie? Can't have him, Courtney. Where are we? Xavier, do you understand this?
Yes, sir, but I have a question. Shouldn't be 2, 6 in the intersection?
Why would you put 2 in the intersection?
Because it's 2 different sets.
Why would you put 2 in the intersection?
Or not 2, I mean 2, 6, because there's a 6 in P and there's a 6 in Q.
Oh, shouldn't there be 2 sets? Is what you're saying?
Yes, sir.
No. 6 is in both of them. That's why it goes in the middle. So they share this number.
Yes, sir.
You see what I'm saying?
Yes, sir.
Okay. D'Angelo, where's D'Angelo? D'Angelo, can you hear me? Is D'Angelo even here? I don't even think D'Angelo is there. Where's D'Angelo? D'Angelo, are you there? Okay. No, D'Angelo is not here. Nakaria, do you understand this? Where's Nakaria?
Yes, sir. Easy busy.
Okay, and Kaden, do you understand this? Where's Kaden? Where's Kaden? I can't have him. Kaden and Jerusalem, do you understand this? Where's Jerusalem?
I'm right here. Yes, I understand.
Okay, good. Perfect. What I need y'all to do is take a picture of this and send to me via WhatsApp. I need everyone to do that. Go ahead and take a picture of this and send to me via WhatsApp because we're gonna move on from this. Again, take a picture of your work and send it to me via WhatsApp so we can move on from this. Alea, you understand this? And Cleveland, do you understand this? Let me know, please.
Yes.
Yes, sir.
Good, perfect. All right, so let's move on from this so we can go on to the next part. So let me show you all a fancier version. So my fancy version, where is it? Good, this is my fancy version. So let me erase all this. Saying the same thing. We have the 3, 9, and 6, 2, 4, 8, and 10. The 6 is connected. 1, 5, 7. And the universal set is there. So that's good. Okay. The next question that we have, so we're gonna answer questions based on this, right? So good. This is, I want B. So this B, okay. So the next question is, we wanna figure out, okay, so what is going to be the intersection? That's pretty easy.
6.
Yeah, P intersect
Q.
Q, yeah. So let's go ahead and answer that question right now. So state the members, okay? State the members of the following. We start off with this one. State the members of P intersect Q. All right, now, how do we read this? Let me write explicitly. How we read this? We read this as, right? We read this as, by the way, write this down as well. But we read this as, let me put this here. We read this as P intersect, P intersect, P intersect what? Q, right? And what does that mean? What does that mean?
What they both have in common.
Yeah.
They both have
Yeah, so elements in what? In what? In common. So what elements do we share? Okay, what elements are in common? Or basically the one that is in the middle, basically. Okay, that's what we want. Okay. The one that's in the middle or the ones that they have in common. So if we go at our graph here, we can see what elements they have in common. Okay.
Is that upside down U is called null?
Say it again.
Is the upside down U called null?
No, the null, that's a good question.
That's an empty set.
Yeah, the null is the empty set. So if we have this one,
Oh.
this is the empty set or the null set, right? Null set
It
or
looks
empty
like kind
set.
of something
It's
else.
Mr. Petit, and just the curly bracket by itself is null too, right?
That's correct. So this null or empty set. Okay, so class, what is going to be a part of the intersection?
6.
Very good, 6. So my number is 426-8891 for those of you who needed to send the work.
Pardon me, Mr. Petit.
No, I'm saying my number is 426-8891 for those who need to send in their work like that.
Well,
All right,
I wanted to let you know that I can't send it from the phone I would generally send it from, and my mom has her phone right now, so I gotta wait for her to come back, and
No
I'll
problem.
send you 2 days notes also.
That's fine. What do you call you, caller?
Pardon?
What do you call your sister?
I said my mom.
I thought you said you would send Legacy's notes too, that you said?
No, so my notes from yesterday.
Oh, okay. Okay. All right, so why did we have 6 as the answer? Do we know?
Because
that's the
6
element
is
in
common in
common.
between P and Q.
Very good. It's the one that's in the intersection. All right. That's why we have that in the middle. So we have that there. Antoine, you understand why you have 6 there? Antoine.
Yes, sir.
And Isaiah, I think that's how you pronounce your name. And Isaiah. Where's Isaiah? Can't hear from Isaiah. Aiden Deal, where's Aiden?
Right here, sir.
Why do we have 6 and as the answer?
Because 6 goes into both. What do you call it? Because 6 is within the intersection.
Very good. So 6 is an element of both sets. And so that's why we have 6 in the middle. All right. And Carmelo Fernanda, do you understand how we got this? Carmelo? Where's Carmelo?
Yes, sir.
Why
Yes,
we
sir.
have 6 in the middle? You said no or yes?
I said yes.
Okay, why we have 6 in the middle?
Because it's common between Q and P.
Very good. Isaiah, are you there?
Yes, sir.
How do you pronounce your name? Asia?
Yes, sir.
Okay, I was trying to call you. Are you in the meeting?
Yes, sir.
So why are you not answering?
I just came on.
Okay. Have you sent in the notes?
I haven't got the notes as yet.
How about from notes from yesterday?
I'll send them in right now.
Yeah, you have to send in your notes, Asia. Your mother is paying for this and you can't be wasting the money. All right? So make sure be paying attention. If I call your name, you have to answer. All right?
Okay. Yes, sir.
Good. So take a picture of your work and send it to me.
Yes, sir.
Good. Okay, so good. Let's go ahead and move on from this. Okay, I think we're good with this. You all understand this, right? I can move on from this.
Yes, sir.
Yeah,
Yes,
so
sir.
Okay. So
Yes, sir.
what if I ask y'all? This is gonna be my second question. So we know that the elements of in the element in the intersection is 6, just 6 by itself, right? Let me erase all link so I can move on to my next question. What if I say this is gonna be C-double-I? Okay, C-double-I. So C-I.
Master Petit, you can go back for 1 second, please.
Go back to what? The
The
previous
question
slide?
before this.
The question before that? The question before that was just this particular graph. We just was showing, let me go back so you could see. That was just this. Quickly take a screenshot. You got it? You got it? I can't have more. All right, so how are we gonna get this? We want the,
Yes,
first
sir.
of all, how do we say this? How do we say
P
this?
union Q.
P union Q, very good, P union Q. And what are gonna be the elements that are in the union?
Everything that is in P and Q.
Okay, Trayvon, give someone else a chance to answer. All right, give someone else a chance to answer.
Okay.
So let's try this again. How do we pronounce this?
Union.
P union Q? P union Q, very good. And what does union mean?
Everything in P and Q.
Everything in P and Q combined, right? Now, do we include any,
sir.
do we repeat any numbers when we do the union?
No, sir.
No, we do not repeat any numbers. So what is gonna be the union? So the union is gonna be everything in P and Q combined. Okay. So put inside the chat the union of P and Q. Put inside the chat. Let me see if y'all on the same page as me. Put inside the chat the union of P and Q. What is going to be the union of P and Q? Where's D'Angelo? D'Angelo, you there? D'Angelo. I could barely hear you. You have to speak into the mic.
Yes, sir.
Okay, good. So D'Angelo, are you writing this down or you haven't started writing yet?
I finished writing it.
Okay. So when we say, what does this mean? Like this, what does this mean? Do you know what this means?
No, sir.
All right, we call this P union Q. Say that. Say that, D'Angelo. We call this P union Q. So say that.
P union Q.
Good. Now, P union Q means that we want everything in Q, so everything in P and everything in Q put together. All right. Everything in P and everything in Q put together. I'm seeing persons put answers inside the chat. Someone put 157. Someone put well, it's 39624. I'm seeing answers in here without curly brackets. So how you expect to let's say, remember whenever we're doing the set, we have to include what? We have to include what?
The curly brackets.
We need the curly brackets, right? We need the curly brackets. And so what does that mean? That means that we have to, what's going to be inside the set?
Pardon me, Mr. Petit. Would 6 be in there too? The union?
Yeah, 6 would be a part of the union. So
Alright,
what are gonna be numbers a part of the union?
Curly
3, 9,
2,
6,
3,
8,
4,
2, 4.
6, 8, 9, and
Let's
10.
do it in order. Let's try to do it in order. So it's gonna be 2,
2, 3,
4,
2, then what?
4, 3,
3,
2, then what?
3,
3,
3, very good. Then what?
4,
4,
Then 4. Then what?
6,
6,
Then 6. Then what?
8, 8.
Okay, 6 is inside P and Q. So what does that mean? Do we have to write it twice?
No,
sir. Only one.
You sure we only write this once? What is
Yes,
inside
sir.
P
Yes,
and
sir.
Q? It's inside P and Q. So do we write it twice?
No,
sir.
sir.
Only once, right? 6, and then what else we have? It's gonna be what?
and
8,
8,
8,
9, 10.
and what else?
9,
9,
and 10.
9 and then 10.
9, and then what else?
And 10.
And 10. Very good, and 10. And 10. Okay. So it's 2, 3, 4, 6, 8, 9, and 10. Does that make sense to y'all? Let me know if that makes sense, please.
Yes, sir.
Again,
Yes,
let me know
sir.
if that makes sense. All right, good. So D'Angelo, what are the elements in the union of P and Q? What elements are in the union? D'Angelo.
2, 3, 4, 6, 8, 9, 10.
Good. Those are going to be the elements outside the union.
Excuse me, Mr. Petit.
Yes.
What about the little n?
And
The little n, then you have the curly bracket, then you put this there.
oh. That means the number of elements. Yeah. Okay. All right. So we got that, right? Class, do y'all understand how we got the union? Let me know if y'all understand how we got the union of P and Q.
Yes, sir.
Make sense? Antoine, you understand how we got the union?
Yes, sir.
And Charlitha, do you understand how we got the union? Where's Charlitha?
Yes, sir, I do.
And Shavarian, do you understand how we got the union?
Yes, sir.
What are the elements that are inside the union, Shavarian?
2, 3, 4, 6, 8, 9, 10.
Why are those numbers are part of the union?
because that's all the numbers inside P and Q.
Very good. Good. So let's go ahead and move from that. So the next one that we have, seeing that we all understand that, is going to be triple I, and I. The next thing I want to ask is, after you already know what's in union, right? I want to know, what I want to know is, what's going to be here. First of all, how do we pronounce that?
P complement.
P complement. Very good. What does P complement mean?
All other elements that are not in P.
Say it again.
All other elements that are not in P.
Very good. All elements that are not in P. Okay. So let's go. Let me erase all this. So what does that mean? That means that we have to mark this off. So mark off P. So we do not include 3, 9, and 6. We do not include that. So you mark that off. Okay. Okay. So what are going to be the elements inside of P complement?
Do we use the universal?
3, 9, and 6.
1, 2, 4, 5, 7, 8, 10.
Very good. So we include all of the numbers
Except for union.
except for P. Okay. So all numbers except for P, right? So that's going to be what?
Question.
1,
1
2.
second. Let me do this properly. Let me do my curly brackets with sense. So we have
See that question. Where come 11?
1. That's a good
2.
question. 11 supposed to be here. So 1, 5. Oh yeah, 2 is there, right? Yeah, we're doing an order. So 1, 2. What else?
4.
So 1,
4.
2,
4.
4.
5.
4. 1, 2, 4, 5.
7.
5. 7.
8.
8.
Yeah.
And
7.
10.
10 and 11.
And 11.
7.
11.
8. Yeah. 8. 10.
10.
11.
And 11.
10 and 11. 11. Very good. So those are going to
Mr.
be the
Petit, why we don't add the 6?
Who said that?
Maya Leo.
That's a good question, Maya Leo. 6 is part of P. Okay. So we don't add any element that is a part of P. Even though 6 is also part of Q, but 6 is part of P. So we do not include that. We only include all of the ones that are outside of P is what's included. Does that make sense?
Yes, sir.
Okay. Class, do you all understand this? Let me know, please, before I move
Yes,
on.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good.
Yes, sir.
That's only like 5 of you. The rest of you, do you understand this? Let me know, please, if you all understand this. Let me know if you all understand.
Yes,
Okay.
sir.
All
I
right,
was
we
gonna
have.
ask the same question which she asked.
Okay, that's good. Let's go and do one more question on this, and then you all would be sets geniuses. Okay, so let me go ahead and do this. Crimson. Okay, good. The next question is, By the way, D'Angelo, where's D'Angelo?
Yeah, so.
Do you understand how we got P complement?
Yeah, so.
How do we get P complement?
You use any
We have to speak into the mic.
use everything in Q.
Say it again.
Use everything besides P.
Very good. Everything besides P. So what are the elements inside P? I mean, outside of P.
1, 2, 4, 5, 8, 7, 10, and 11.
Very good. Very good. Okay, so that's gonna be, I want the number of elements in Q. Good. So what does this mean, first of all?
Number of elements in Q.
Very good. So let me go ahead and write this down. So this means, right? For those of you who do not know what it means, it actually means we want the number of elements, let me change the font, not font, but the color. Let's change the blue. So we want the number of elements, right? In Q, in set Q. Okay, the number of elements in set Q. So what are the elements, the number of elements in Q? So first,
5.
let's list off Q, right? So Q contains
2, 4, 6, 8, and 10.
Very good. So Q is gonna contain, let me erase all this. Erase all of this. All of this, all of this, all of this. Okay, so let's use a green. So is 2 a part of Q?
Yes, sir.
Yes, sir.
Mm-hmm. How about 4?
Yes, sir.
Yes, sir.
Mm-hmm. How about 8? I mean, how about 6?
No,
Yes,
I mean
sir.
yes, sir.
Yes,
How
sir.
about 6?
Yes, sir.
Yes, sir.
No,
How
sir.
about, how
Yes,
about
sir.
6? How about
Yes.
6? It's
Yes,
6.
sir.
It's
Yes,
6
sir.
in Q. It's 6 in Q.
Yes, sir.
Yes, sir.
Sure.
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir.
But 6. But I know that 6 is a part of P. So why y'all tell me that 6?
6 is in both.
Because 6 is in both.
But if
It's
you
also inside Q.
Very
if you
good.
circle the whole Q, you will see 6 inside the
Very good.
the oval.
Excellent. So 6. How about 8?
Yes, sir.
8
Yes,
is
sir.
clearly there. And how about 10?
Yes, sir.
10 is
Yes,
clearly
sir.
there, right? So 2, 4, 6, and
10.
10. Very good. So how many elements are inside of Q? This is 1.
5.
5.
This is 1. This is 2. This is 3. This is 4. And this is 5. Okay. So that means the number of elements in Q is going to be 5. Do y'all understand that, class? Let me know, please, if y'all understand that. Let me know if y'all understand this, please.
Yes, sir.
Yes, sir.
Okay. What I need y'all to do, put I inside the chat if you understand how to do this question. Put I inside the chat if you understand how to do this question. Put N if you do not understand how to do this. But put I inside the chat if you understand how to do this. Put N if you do not understand how to do this. Okay, put I inside the chat if you understand. Put N if you do not understand how to do this. Lavender Johnson. Hello, Lavender. Where's Lavender?
Yes, sir.
Do you understand how to do this?
No, can you explain it again, please?
No? Okay. Which part don't you understand?
This last one.
The number of elements in Q?
Yes, sir.
Okay, so the number of elements means how many elements how many elements are inside set Q? So tell me the elements that are in Q. How many elements are in
5.
Q? Say it again.
5.
How many?
4.
Okay, let's count. Is 2 a part of it?
Yes, sir.
Is 4 a part of it?
Yes, sir.
Is 10 a part of it?
Yes, sir.
Is 8?
Yes, sir.
How about 6?
Yes, sir.
6 is a part of both of them, so 6 is a part of Q as well. So how much is that all together?
5.
So the number of elements in Q is what?
5.
That makes sense?
Yes, sir. I didn't realize the in the middle. I
The
didn't
6
realize.
is, yeah, the 6 is also there. Again, put I inside the chat if you understand, put N if you do not understand how we got the answer. Okay, put I if you understand, put N if you don't understand. You all know what to do. What I need you to do is take a picture of your work and send it to me via WhatsApp again. Take a picture of your work and send it to me via WhatsApp. Valea Miller, where's Valea? Valea, can you hear me? Where's Valea? Where's Valea? Valea, can you hear me? You can't unmute. No, you can't. You can't unmute Valea. If you look, I already unmute you. Oh, try now. Try to speak now, Valea. Can you speak now? Valea, can you hear me?
Yes, sir.
Okay. Have you sent in your notes, Valea?
No, sir. I'm working on it right now.
Did you send in your notes from yesterday?
Yes.
Pardon?
Yes, sir.
Valea. Let me see. Okay, I see it. You have to consistently send in your notes because some days I don't see you send in your notes, Valea. You understand me? So you have to consistently send in your work.
Excuse me, Mr. Petit.
1 second, I'm speaking to Valea. Valea, you hear me?
Yes, sir.
Good. Go ahead, Trayvon.
Excuse me, Mr. Petit. I was saying if I was asking you a question. If N bracket Q union P bracket complement equal, would it be 4? But yes.
Oh yeah, it would be because 11. I didn't put 11. It would be 4.
Mr. Petit,
Uh-huh.
we had a test about not sets. What? Yeah, sets. We had a test about sets
Yeah,
today.
they always ask you questions about sets. Sets is gonna come on your exam, guaranteed. Guaranteed sets coming. I don't gotta worry about that. Okay, so good. So we finished with this. So I'm gonna move on from this. I think that's enough of sets for today. Let's move on to what's the next thing he's gonna do? Mensuration. What time is it? It's 7 o'clock. I don't understand how this time rolling, but it's just moving. Like we just started class. I don't understand this.
Surprising. So let me guess, because the days change, so Saturdays and Fridays gonna be longer instead of school being longer.
No. That's not how it works, buddy.
You sure that clock don't be set on the wrong time?
That's not how it works, son. All right, so we're gonna do mensuration. Okay, I think we're good. Okay, good. This is a good question. I like this. Okay, good. So write this down for me, please. And also draw the image as well. Is Jada here? I don't think Jada is here.
Excuse me, Mr. Petit. It's showing blank.
You see it now? Okay. You can see
Yes,
it now?
sir.
Okay, good. Joseph Kalma, where's Joseph? Joseph Kalma. Joseph Kalma, can you hear me?
Yes, sir.
Go ahead and read the question for me. the width of the rectangle?
Mr. Hancock, again, I see the width of a rectangle is 2x. Take away 5 centimeters, and the length is x centimeters.
Write and simplify. Write and simplify.
Write and simplify an expression for the
perimeter.
Perimeter of the rectangle.
Very good. Okay, go ahead. Cleveland, read this question for me, please.
The width of a rectangle is 2x minus 7 centimeters, and the length is x cm.
Okay.
The rectangle 2x minus 7 centimeter, the other a smaller side x centimeter, and I repeat, not to scale.
Thank you.
Write and simplify an expression for the perimeter of the rectangle.
Good. All right, so let's go ahead and do this. So what we want to do is we want to first we need to write the expression, and we need to simplify it. Does anyone have an idea of how they think they could do this?
Yes, sir.
Not you, Trayvon. Let's give someone else a chance. Does anyone else want to try it? Write and simplify an expression for the perimeter of the rectangle.
Perimeter is like when you add up all the sides, so it was 2x minus 5 centimeters plus x plus 2 is 5 centimeters plus x. And then you just put it inside the like correct terms. And then you
Very good, very good. So she made a good point. Notice that this what shape is this? This is a what?
Rectangle.
Rectangle. So because it's a rectangle, right? That means that if this side is 2x minus 5, then what must this side be?
The same thing.
The same length, right? The same length. So this is gonna be what? 2x minus what? Minus 5. And if this side is x centimeters, right?
Then the other side should be x centimeters.
Then the other side should also be x centimeters as well. Very good. So both is going to be x centimeters.
I ain't even gonna say vertically opposite angles.
I hope not. All right, so now perimeter means that we want the length along the boundary, right? Like how long it is. Add. Okay. And so with that being said, we have 2x minus 5, so 2x minus 5. Let me have 2x minus 5 plus what? So we have 2x minus 5 plus what?
2x minus 5
plus x, right? Plus x plus what?
2x minus 5
plus 2x minus 5, yes. Plus 2x minus 5. Plus what?
plus x.
Plus x. Okay.
Oh, Mr. Petit.
You got your answer?
Yes, sir.
Yes, okay. If you got the answer, you could put inside the chat for me. Laura, what are we gonna do at this point? Here's Laura. We want to simplify it. What are we gonna do, Laura, to simplify it?
We are going to,
Mr. Petit, can I try?
Go ahead, try. What are we gonna do to simplify it? Go ahead.
Put the ones would look alike together. And basically I draw a line under that X and draw a line under that X and then put it as 2X at the bottom. And then I draw a line under the 2X and the next 2X minus 5 and make it 4X minus 10 and keep going.
Okay, good. So what we do is we have to group them together, right? All of the like terms we group together. So 2X is grouped together. Okay. Plus X is grouped together. So all of the terms.
I thought they was gonna keep that 2X minus 5 as one thing.
No. We group all of the X's, right? So all of them we group together. This is grouped together along with this, along with that. The rest of you class, are y'all following? Y'all understand what we're doing?
Yes, sir.
Let me know if y'all understand. Jasmine, Rose, Jada, Jemiah, Joel, Jerusalem. Y'all understand? Y'all understand? Okay. So we're gonna do what? It's gonna be equal to what? 2X plus what?
Plus 2X.
Plus X plus 2X plus what?
X.
Plus X. Very good.
Minus 10.
Minus 5.
Then we're going to group together the
5s.
The 5. So it's going to be -5 and also
Negative
-5.
5.
Right? We put them together. So this goes along with this. So it's going to be -5, -5. Okay.
Or -5 minus 5.
Or -5 minus 5. Very good. Cavante, Capron, where's Cavante? Are you there? Cavante, Capron, can you hear me? Tiana from Cavante. Ivory, can you hear me? Where's Ivory? I don't know if Ivory can hear me. Where's Durante Smith? Durante, can you hear me?
Yes, sir.
Durante, can you hear me?
Yes, sir.
What is 2X plus X?
2X.
What is 2X plus X? Anyone want to help him? What is 2X plus X?
3X.
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 3X. I just do this in class.
3X, very good. Plus, what is 2X plus X?
3X.
That's going to be 3X, very good. 3X.
Mr. Petit. When would it turn into the power of something?
When you're multiplying.
Oh, yes, sir.
When you multiply. And then we have -5
And a -5.
-5. That's going to be what?
+10.
That's not true. -10.
-10.
-10. It only works like that when you multiply. And so if you say -5 times -5, then it becomes +10. I mean, it will be +25. All right. if you're multiplying it. Okay, Trayvon? So, so we have 2x plus x is 3x, 2x plus x is 3x, and then it's gonna, so we good, right? We finished with this, right? We could, we're done, right?
No, sir.
No, we still have more steps to do. What else we have to do?
Add the x's.
So 3x plus 3x is gonna be what?
6x.
6x, very good. And then we just bring down the
Negative 10.
minus 10. Let's bring down the minus 10. It's gonna be 6x minus 10. And
CX.
then we're gonna do 6x minus 10. What is 6 minus 10?
We can't do it because it's unlike.
It's
We
unlike.
can't. So we have to keep it at 6x minus 10, right?
Yes, sir.
Very good.
You forget the CM.
Are we gonna simplify it like divide by 2 or something?
This is just an expression. They say expression.
You forget your units.
Where we just write an expression. We don't need the CM. So 6x minus 10 is the answer. Do y'all understand how I got this or no? Let me know, please, if y'all understand how I got this.
Sir.
Tayden,
Yes, sir.
Johnny. So all we do, the
sir.
first thing we did, we just combine the like terms. And then once we combine the like terms, then we operate on the terms that we combined it. We combined, all right? Say combined it. We combined. So what we did, we say first we start off with 2x minus 5x, 2x minus 5x. Then we bring together all of the x terms. So 2x, x, 2x, x. Bring all of them together. And then we bring together all of the numbers. So it's going to be negative 5, negative 5. Negative 5 minus 5 is 10, negative 10. And then what we do 2x plus x is 3x, 2x plus x is 3x. Then we do 3x plus 3x, which is going to be 6x. So what we have is 6x minus 10, 6x minus 10. Again, do y'all understand how I got this expression? Let me know, please, if y'all understand that. Before I
I
move
do.
on to the next one.
Yes, sir.
Good. Is there anyone who do not understand how I got this? You do not understand how I got this? Let me know, please. If you don't understand how I got this. Danaj Moss, where's Danaj Moss?
Yes, sir.
Do you understand this?
Yes, sir.
Explain how we got 6x minus 10.
Okay, we got 6x minus 10 because we added up the 3x, the two 3x's that gave us 6x, and then we added up the 5x, the 5 minuses.
Good, very good. And D'Angelo Smith? Where's D'Angelo Smith? D'Angelo, can you hear me?
Yes, sir.
Where's D'Angelo? D'Angelo, can you hear me?
Yes, sir.
D'Angelo, have you written this down?
I'm writing the last, the one we say negative, subtract 10.
Okay. What I need y'all to do is I need y'all to send in your work. What we're going to do is we're going to finish this off. So send in your work, please. Take a picture of your work and send it to me via WhatsApp. Let's go on to the next question. Let me move this. Again, take a picture of your work and send it to me via WhatsApp. Everyone should be finished with writing this or close to finish. So let me put this in the chat. Let me put this here. Let me move all this stuff. Clear all drawings. Clear all drawings, good. So we have, let me pause this. All right, let's go ahead and answer these two. Go ahead, Jada, read the question for me, please. The perimeter. The perimeter. Jada, where's Jada? Kind of from today. Jada, Destiny Taylor, where's Destiny?
Yes, sir.
Go ahead and read the question, please, both of them. By the way, please write this down again. Please write this down.
B. Using your answer in A, form an equation for the perimeter of the rectangle. C. Solve your equation.
Very good. And Devana knows. Where's Devana? Devana. Kiana from Devana. Elkanick Lloyd.
Yes, sir.
Read the question for me, please. B and C.
Okay. Using your answer in A, form a equation. That's right, yeah.
Yes, equation, yes.
Equation for the perimeter of the rectangle. Solve your equation.
Very good. Okay, I want to figure out what is how to form this equation. Ivory. Where's Ivory? Ivory, where's Ivory? Can't really hear from Ivory.
I'm ready.
Ivory, can you hear me? That's Ivory. Okay. Can someone help me? How are we gonna answer this question? Part B.
I could do it.
No, not you, Trayvon. Someone else. I want to form the equation. Not you, Shania. Give someone else a chance. I know Trayvon and Shania, y'all know. Anyone else? How are we gonna form an equation to get this?
Rectangle.
No.
Mr.
We're
Petit.
gonna use our previous.
No, not Ralph or Genesis. Someone else. I want to form an equation for the
I
perimeter.
actually don't know how to do it.
Oh, you don't know? Okay.
I was gonna guess.
Anyone else want to try? Form an
Can I try?
equation of. Go ahead, Daniel. Okay, that's a good person. Try.
6x minus 10 equals 14 centimeters.
Say it again. Say it again.
I said 6x minus 10. 6x minus 10 equals 14 centimeters.
Equals to 14. Where you get the 6x minus 10 from? Where did you get the 6x minus 10 from?
From the answer from A.
From the answer previously, right?
With the answer from A.
And why you said it equals to 14? Why did you say it equal to 14?
Oh, I understand.
Why did you say it equal to 14, Danielle? We can't.
I know.
You don't know? You're just
Yeah.
guessing. All right. Anyone want to help him? His
I
answer's
think
correct,
I
by the way.
understand.
Because
Why?
it said
Because it's a
14 centimeters, so how do we equal to 14?
Jamaya, thank you, Nakaria. Very good answer. Jamaya, you have a question or you want to input something? Jamaya? Where's Jamaya? I see your hand raised. Jamaya, we can't hear you. So what we did, yes, go ahead, Jamaya.
Because the perimeter of the rectangle is 14 centimeters.
Very good, because the perimeter of the rectangle is 14, okay? And so when we remember what we had here, right? We had, obviously we had 2x minus 5, right? 2x minus 5. And we had x, okay? And we had x. And we had 2x minus 5. Here's the thing. When we add all these up, right? So when we add all them up, okay? We add all them up. So we add the 2x minus 5, and we add the x, and we add the 2x minus 5, and we add the x. When we add all them together, right? We got what? 6x minus what? Minus 10. That's exactly what we got here. 6x minus 10. Okay? So what that means is we're going to use this answer, the same thing we got in the previous question. We're going to use this. And so we have 6x minus 10, and we're going to set it equal to 14 because 14 is the perimeter, right? Both terms are expressions for the perimeter, so they must be equal, all right? So that means that 6x minus 10 has to be equal to 10, has to be equal to 14 because both of them represent the perimeter. Okay, does that make sense to y'all? Let me know, please, if that makes sense to
Yes,
y'all.
sir.
Okay, so why did I erase? Oh my goodness. I didn't mean to do that.
Oh, can I try to solve the equation? I think I know what to do. I think.
You,
What
Crimson?
you mean me? Yes, well, I think.
You know how to do it?
I think so.
You think so? All right, so let's go ahead and solve it. Go ahead, Crimson. We're gonna solve it.
Okay. So
So-
we like
So
we'll
let's
rewrite it.
rewrite it. 1 second. It's going to be this. So we have 6x minus 10 is equal to 14. What else?
So basically you move the negative 10 over by the 14. So that would give you 6x equals 14 minus 10.
So when we're gonna send the 10 over the equal sign, but when we send it over the equal sign, it doesn't remain negative.
It turns into a positive.
Very good. So it's gonna be 6x. What? 6x is equal to
14 plus 10.
14 plus 10. 14 plus 10. 14 plus 10. Then, what is 14
That
plus
was
10?
24.
14 plus 10 is 24. Very good. So that means we have what?
6x equals 24. And then
6x
you
equals 24.
move the 6 over to the 24, which would be 24 divided by 6.
Very good. So we divide both sides of the equation by what? By
6.
by
6.
6. Oh, very good. So that means that we cancel this 6 with that 6. So x is equal to
4.
4
x is equal to
is equal to 4.
24 divided by 6.
4.
24 divided by 6 is 4.
And 24 divided by 6 is
4.
4. Excellent. So x
I
is
didn't
equal
even know what I
to
was doing.
Very good. So x is equal to 4.
Mr. Petit, so you telling me if we go back all the way to the top and we plug in 4 where
Yeah.
we see x all over them places, that's supposed to equal 14?
That's correct. You could try it. Yeah, you could try it. That's exactly what that means. That's exactly what that means. All right.
I'll try it at work tomorrow.
All right.
That's exactly what we did.
All right. Class, do y'all understand how we got x is equal to 4? Because I'm on here
Yes, sir.
from a few of
Yes,
y'all.
sir.
do
Fine.
y'all-
One more time, please.
Which part? The equation or the
The whole
expression?
thing.
The whole thing? Okay,
Mhm.
so what in order for you to really understand this, we have to go back to the previous slide. Where in the previous slide, you saw we got 6x minus 10, right? That was the expression for the perimeter. Okay? You understand that, Alora?
Yes, sir.
Now what we're gonna do, we're gonna take 6x minus 10, and when we come here, they say that the perimeter is equal to how much? What is the perimeter
14
equal?
centimeters.
Very good. The perimeter is equal to 14. What does that mean? That means that if I set 6x minus 10 is equal to 14. If I set them two equal to each other, that's going to be what? That's going to be the equation. All right.
Yes, sir.
Okay, that's going to be the equation. So we set them equal to each other, and that's going to be the equation. Okay. And so once we get the equation now, all we need to do, okay, all we need to do is, once we get the equation, all we need to do is take the 10, send it over the equal sign, right? And Laura, when we take the 10, we send over the equal sign, that becomes what? It was a negative 10. When we send over, it becomes what?
A positive 10.
Positive 10, very good. So 10, send over, it can become positive 10. 14 plus 10 is what?
24.
24, very good. Next thing we do, we divide both sides by what?
6.
We divide both sides by 6. So cancel, cancel. So x is equal to, what is 24 divided by 6?
4.
4. So x is equal to?
4. X equals 4.
Because 24 divided by 6 is?
4.
It's 4. Very good. All right, and so that's how we go ahead and do that. Okay. What I need y'all to do is take a picture of this and send it to me via WhatsApp. Again, take a picture of this and send it to me via WhatsApp. Class, do you all understand this or no? Let me know if you all understand this, please.
Yes, sir.
Yes, sir.
Good. Let me go ahead and mute you up. What I need y'all to do is take a picture of your work and send it to me via WhatsApp, please. Again, take a picture of your work and send it to me via WhatsApp. Waterfall, do you understand this? There's Waterfall. Waterfall, do you understand this? I can't have from Waterfall. Shaved Harris, do you understand this?
Yes, sir.
Okay, and Ren, do you understand this? Where's Ren? Ren, do you understand this? Can't really hear from Ren. Jervin, do you understand this? Where's Jervin? Jervin, do you understand this? Okay, good. Okay, let's move on. Let's move on from this. So we already did sets, we already did mensuration. I think that was the last question on mensuration. So let's go ahead and do, what was the last topic we said he's gonna do today?
Probability.
Probability.
Yeah.
Oh, actually, there's one more question. There's one more question on this thing. Before we move on to probability. One last question. And it states, let me erase all this. Keep one more question on this. Let me erase all link. Cloud joins. Boom. So the last question is calculate the area of the rectangle. Calculate the area. So how did I do this? We know that if you look carefully, I think what's her name? We know x is what? X is, based on the question, x is
4.
X is 4, right? So if x is 4, that means that this is how much? Centimeters.
4
So
centimeters.
this has to be 4. Why? Because x is what?
4.
X is 4. But we need to figure out what is 2x minus 5. Now, 2x minus 5, which means that we have to put x wherever we see, we have to put 4 wherever we see x. It's going to be 2, open bracket, 4, close bracket, minus 5. Okay. It's going to be equal to 2 times 4 is what? 8 minus 5. What is 8 minus 5? That's going to be what? 8 minus 5 is? 8 minus 5 is? What is 8 minus 5?
3.
8 minus 5 is 3. Very good.
3.
And so, what does that mean? That means that we have 4 centimeters here for this one. We have 3 centimeters for this one. And so we have 4 centimeters times 3 centimeters. And that gives us 12 because the length here is going to be 4 centimeters. The width is going to be 3 centimeters. And we know, what's the formula for area of a rectangle? What's the formula? For area of
Length times width times height.
no, area of a rectangle. Area of a rectangle.
Length times width.
That's length times width, right? So we already know that the length is what? 4 centimeters. And we know that because that's x. X is 4. Okay. Okay. And we also know that the width is 3 centimeters. And we just figured that out. 2x minus 5, right? Two x minus 5. And so we say 2 times 3. 2 times 3, 3. We know 3 is x. I mean, not 3. We know 4 is x. And so 2 times 4 is 2. 2 times 4 is 8. And then 8 minus 5 is going to be 3. And so that's how we got this 3. And then so 4 times 3 is going to be 12. So it's going to be 12 centimeters squared. 12 centimeters squared. Now, centimeters squared, the reason why it's centimeters squared is because we're dealing with what? We're dealing with area. Area. That's why it's centimeters squared. Okay.
Mr. Patel, which one is length times width times height?
Length times width times height. Can someone help her? What is length times width times height? What is that?
Wait, I thought it was base times height times
Length times width times height is what? When we do length times width times height.
The volume.
That's the volume. It's the volume of a cuboid.
Oh, thank you.
Yeah. Okay. Class, do you all understand how I got 12 centimeters squared, or I need to explain that again? Let me know, please.
Just one more time.
Okay, so let me go ahead and explain it again. So first, right, what I did, let me erase all this, clear everything. So clear all drawings. So what I did was, I realized that this is x. But I know what x is based on my previous question. I know that x is what? I know that x is 4, right? I know x is 4. And so what I'm gonna do is I say, okay, well, x is 4. So if x is 4, what's going to be my width, right? And then the previous question, if we did this, we didn't do state the width of the rectangle. But if we did this, it's supposed to be the question before this, by the way. We know that 2x minus 5 is going to be 2 times 4. 2 times 4 is what? Is 8, and 8 minus 5 is 3. So that means that x is 4, and 2x minus 5 is what?
3.
Is 3. Very good. And so again, x is 4, and 2x minus 5 is 3. Okay. And so all I need to do is multiply it now. So we have 4 times 3, and 4 times 3 is going to be 12 centimeters squared. And that's going to be our answer there. All right? Yes.
I was gonna ask you, so
go ahead.
6x minus 10 equals 14.
Say it again.
I said if you're gonna put it as a division sign, would it be 144?
Say it again.
I was saying if you put it as a division sign, would it be 144?
I don't understand. Say it again. What you're saying? If we would have what?
I was to put x over 6 minus 10 equals 14, would it be 144?
Why are you dividing it?
No, you could, some questions might have it like cut x.
I can't hear you at all. Your it's like it might be the fan is on or something, but I can't hear you properly. All right, so let's go. Class, we have this written down before I move on to the next one. Let me know, please.
Yes, sir.
Yes, sir.
Mr. Petit,
Go ahead.
what is the formula for perimeter, please?
Perimeter is just
Adding up all the
adding up all of
sides.
the sides, yeah.
Add up all the sides.
Yeah. That's all it is.
Yes.
Okay, good. All right, let's move on from this. Okay, so the next thing we need to do is we need to do probability. I think that's the next thing we say it's gonna do. Probability. So how many persons have learned probability before? You did probability in school?
I
or-
have.
Yeah.
I have.
Okay. What is probability? What is probability?
Probability is basically like chances when you like.
It's
I
kind of
can.
like fraction or percentage.
It's like, say it again.
It's kind of like fraction or percentage.
Fractions of a percentage. Okay. But what is probability? What is that? What is that?
An activity with
Oh, the chances.
The chances.
Something is possible.
an experiment.
An experiment. Okay.
Possible chances.
The possible chances. Anyone else? What do we mean by the probability?
How likely something may happen between 0 and 1. The chances 0 and 1.
Who said that?
Ronaldo. Okay.
Very good answer. So the probability is basically, we say it's the likelihood, right? The likelihood of something. That's let me probability is the likelihood of an event occurring, right? Probability, how can we express probability? Can be expressed
Percentages?
as, you would express probability as a percentage?
Like 50-50? Not percentages, but like a 50% chance of this happening, 80% chance of that not happening.
We express probability as percentages, really?
Yeah.
Class, how can we express probability?
As a decimal?
As a ratio or fraction.
range?
As a ratio or range. Okay.
Fraction.
Fraction, decimal.
Use words like most likely or impossible.
So a probability can be expressed as a fraction. It can be expressed as a decimal. And yes, Crimson, it can be expressed as a percentage.
Okay, thank you. I thought I was going crazy.
I thought I
Alright.
got all of them wrong.
All right, next, if a probability is 0, right? So if the probability of 0, if the probability is 0, what does that mean?
Not happening.
There's no chance.
There's no chance of it happening.
Yeah, it means that the event is impossible, right? If the probability is 0, it means that the event is impossible, right? We can say the event will not happen,
Possibility of miracles.
right? It is impossible. So probability of 0 means that the event is impossible. It cannot occur. It will never occur, right? So if I say, what is the problem? Give me an event whose probability is 0.
A cow flying over the moon.
Wow, you in my head now. Yes, the cow flies over the moon. What else? Probability.
The planet on
The dog
Jupiter.
being able to graduate from college.
Say it again.
The weather, like the chances of it to rain.
0?
The universe on my dinner plate.
The universe on my dinner plate. I like that. The universe on my dinner plate. Wow.
The government is taking our money.
The government what?
Not taking our money.
Hold on, I must have didn't hear the question right.
Genesis, that's cruel.
You have to pay taxes.
Did you see mine?
What's the probability of Antoine becoming a prime minister?
50-50.
0.
50-50. I'm a hater. 50-50.
If you cancel taxes, then
Not
yes,
good to
you will have
hate.
it.
50-50.
You know what? I'm gonna be nice. 76.
Oh wow! Thank you. Okay, Aiden.
50-50.
Say anything.
80%.
Okay, Aiden.
80%.
More like.
Can't hate. 50-50.
All right. Is it in the probability of 0? Y'all didn't think it's probability of 0?
I wouldn't say that.
Nah.
You want to say that?
I think that's kind of
We gotta
mean.
give him a chance, though. We gotta give him a chance.
All
Yeah,
right.
I think it's kind of mean.
Okay. If the probability is 1, it means what?
It has a very low chance.
Very low chance.
No. No.
Not too.
1%
It's like a
chance.
good chance.
No. If the probability is 1.
Slim to none.
No.
There's a
No.
1% chance it happens.
No. If the probability is 1.
Rare.
No.
Have a chance.
No.
It has a
That's a guaranteed chance of it happening then.
It means that.
It will happen.
It means that
It will happen.
the event.
It can happen.
That the
It means
event.
that the event can likely, it can happen.
It will certainly happen. Right? Guaranteed.
Oh, not 1%, just 1.
1, not 1%. 1.
Hey,
Right? It's guaranteed. It doesn't. It's not no likelihood that will happen. Right? 100%. Right? It was. So that means it's 100% chance that it will happen. All right. So, is it 100% chance that all of y'all become millionaires? Is that 100% chance?
Yeah, so actually,
No.
Oh no.
Yes.
No.
I'm
Them-
really lazy on
no.
Saturdays
Them
and
no.
Fridays, so
Not
please
with them.
No.
I would say the probability of. I wouldn't say 0.
Y'all 0%
0.6.
of y'all becoming millionaires? Wow, 0.6.
Wait, keep yourself.
About that, but
100%.
Believe in yourself.
That's on
More of the nice, good 93.
All right, let's do it. The probability of y'all graduating college is what?
a 1%.
That depends if you
100%.
I could
1%.
see.
100.
No, it
Feel
depends.
like get in trouble and stuff, then the thing go low.
85 is like.
Other than that, it's 1%.
1%.
I'm
Wow.
gonna give a solid 85 if I even go to college.
95.
Not
85?
1%. A probability of
1%. Wow. Okay, give me something that has a probability of 1. That's guaranteed to happen.
oxygen is on
The
Earth.
sun will be
The sun exploding.
visible this month.
This is the summit.
The sun would be visible this month. I like that.
We all dying right now.
Day is my
Humans would-
birthday is this month.
Your birthday is
We
this
all
month.
dying right now is a probability of 1.
That's true. We haven't. I like that.
Probability of 1 that we have class tomorrow.
Well, we don't know.
A baby
not-
would be born.
That's not
That's
guaranteed.
guaranteed gonna happen.
That's like a baby will be
You
born.
can inhale oxygen.
Yeah.
You can inhale oxygen. Well, we know God will never die, so that's a probability of 1. Ain't nothing happening.
That's a good one, yeah.
That's the probability
Yeah.
of 0
That's
because
0, not 1.
It's 1. 0 means it's impossible.
It's impossible that God dies.
And then probability of 1 is, if I say the probability of him never dying is 1.
literally has levitation.
Okay, so okay. Can probability be over 1?
No, no, sir.
No. So probability, if you're inside the exam and you get a probability that is over 1 or less than 0, it's wrong. So probability can never be above 1, and it can never be below 0. So the range for probability is 0 to 1 to 1. So this is the range. So for example, it could be this along this continuum. Okay. So if it's 0, that means it's impossible. If it's 1, that means it's guaranteed to happen. If it's in the middle or half, we say that that's what? 50% chance, 50-50. So a half is 50%. And the probability of heads or tail is what? Probability of heads.
50-50.
50-50, right?
50-50, yeah.
Oh, it's a fraction then. All right.
Right? So it could be a fraction or it could be so 50-50 chance. Okay, next we have it also could be a probability of 3/4. Right? 1 second. And the probability of 3/4 means that it's gonna be what? 75%. Okay. And the probability of a quarter is what?
25.
25%.
Mr. Petit, we have to draw that.
Yes, draw this continuum. So you know who deals with probability a lot? Who deals with probability a lot in their profession?
Scientists.
Scientists, right?
Salesperson.
They-
Do auditors deal with that?
In
Oh,
particular,
yes, meteorologists.
meteorologists do deal with that a lot. So much so if they
Doctors.
say it again,
Doctors.
Their whole
doctors,
profession is basically based on that, really.
say it again.
Meteorologists, their whole profession is basically based on that.
That's correct. That's why meteorologists, believe it or not, are good at math. Well, they're supposed to be good at math, right? Some of them start off with math majors, right?
I'm pretty sure sometimes they just make numbers up though.
No, don't say that. I think there's some accuracy to it. They do it. Okay, so that's what we mean by probability. Anything else we need? Oh, one more thing we need to know. We need to know it's the formula. This is gonna be needed. The formula. So the probability formula. Okay. So here is all this. What's the formula for calculating probability? Okay, what's the formula for calculating? So the formula, y'all don't know the formula? I'm sure y'all know this. Formula for
Mr. Your mic gone. I don't know if it's just me.
Yeah, you're pretty low.
Your mic went out.
All right, the formula for calculating probability. Do y'all know the formula for calculating probability is what?
0 to 1.
No, the formula. If you want to figure probability, what we gonna do? We're gonna do what?
Fractions.
Yeah, but what's the formula?
I'm gonna go with 0 over 1.
No.
Over
No.
total item.
Number of ways.
Say it again, Shania.
Number of outcomes? How much number it is of a specific thing and the total over the total amount of number.
Hold on.
Very good. Very good.
Yeah.
So it's gonna be number of favorable outcomes. So number of favorable outcomes divided by the what? Total what? Total number of outcomes, or total number of what? Possible outcomes. That's going to be the formula for probability. As you can see, it's expressed as a fraction. Okay, so the formula for calculating probability is going to be the number of favorable outcomes divided by the number of possible outcomes. Okay.
Pardon me, Mr. Petit. May I go to the bathroom, please?
Yes, you can.
Thank you.
So you see it, Petit?
I see it. I'd say maybe that's tough. Before the year out?
We should say before the year out. No, we still got some time.
I still got some time, you're right. All right, so the number of favorable outcomes divided by the total number of possible outcomes. That's going to be the formula for calculating probability. Okay, so probability is the likelihood of an event occurring. We can express a probability as a fraction, a decimal percentage. If it's class, if we have a probability of 0, right? What does that mean? Probability of
It
0.
will not happen.
It will not happen. It's impossible.
It will not happen. It's impossible. Very good. What if we have the probability of 1?
Guaranteed.
It is guaranteed.
Very good.
100%.
100% guaranteed. Okay. And then probabilities. What are 3 ways we could express probabilities? 3 ways we could express probability.
Fraction, decimal, and percentage.
Fraction, decimals, and percentage. Very good. And then the formula for calculating probability is what? It's a formula for calculating probability.
Number of favorable outcomes divided by total number of possible outcomes.
Total number of possible outcomes.
Very good. Okay, so there's certain words that you have to be familiar with when we are dealing with probability. The first one is going to be sample space. Sample space. So the sample space is basically the set. So the set of all possible outcomes of a random experiment. And so that's what we mean by the sample space. So basically, the total number of possible outcomes is basically the sample space. So when I say sample space, I mean the total number of possible outcomes. So if I say, right, what is the sample space? So let's say my event is that I am tossing a coin randomly. That's my event, right? My sample space is going to be what? My sample space is going to be what? My possible. Let's say my event
The possible
is that.
outcome?
Let's say my event is that I am flipping a coin randomly, right? What is going to be my sample space if I'm flipping a coin randomly?
The 2 sides. You would have to put the flip side. I mean the front side and the back side is your sample space.
So my sample space is a set, call it S, where I have heads and I have what? And I have
tails. That's what I mean.
Very good. That's my sample space. That's when flipping a coin. But what if I have what if I want to determine my sample space when I am rolling on a fair die randomly?
1 through 6.
All right, so the sample space of rolling a fair die is going to be 1, 2, 3, 4, 5, 6. Now, if I look at my sample space, if I want to know the number of elements in my sample space, what is that? The number of elements in my sample space for this particular experiment.
6.
That's going to be 6. Okay. And the number of elements in my sample space for when flipping a coin is going to be what? Number of elements in my sample space.
2.
It's going to be 2. Very good. So what does that mean? That means that in the formula, instead of saying the total number of possible outcomes, I could just say the number of elements in the sample space. Okay. So the number of elements in the sample space is what could be in the denominator. That means the total number of possible outcomes. That's what that means. Okay. Does that make sense or no? Let me know if you all understand that.
Yes, sir.
Understand? So let's move on from this. I want to introduce one more definition, and that's going to be an event. What do we mean by an event? Okay. All right. Has Sun said yet?
Oh, yes, sir.
Yeah. Event. Do y'all like this time or y'all like the old time?
I love this.
Love it. More tennis for me.
Love
I don't like the night
LOVE.
levels. This time mess my sleep schedule right up.
Why?
When I think I wake up early, I wake up late.
Wait,
Alright.
I used to be waking
I
up
used to
at 5,
wake
now
up
I'm
at
waking up
6.
at 7.
I'm waking up at 8.
You used to wake up at 6, you're waking up at 8?
Yeah.
Yeah, because I used to wake up
Are
at
you
5.
waking
now
up
I'm waking
earlier,
at
Mr.
7.
Petit?
Brother, wake up earlier?
Yes, sir.
Yeah, me too, actually. I waking up more on time now.
Yeah,
No, like it's at the time
early,
moving
like
faster, but it makes it
around,
too late.
All right.
like
So-
around 6 o'clock to get ready.
So a simple event is basically, so let's go to event. So in probability, an event is basically any outcome. So any outcome or a set of outcomes of a random experiment. That's what we mean by an event. Or we can say a desired, or we can say that the event is going to be or put simply, an event is an occurrence of something, right? So when something happens, that's an event. So we could have elements. So let's say, for example, right, I'm rolling a fair die. I'm rolling a die, right? When the dice lands on heads, that's an event, right? So the event is going to be that when I say dice, sorry, when the coin lands on heads, that's an event. So the event is that the coin lands on heads. That's my event. If the coin lands on tails, my event is going to be that what? The coin lands on tails. If I have a deck of cards and I land on ace of hearts, the event is going to be that I land on the what? I land on a what?
Hurry. Ace of hearts.
Ace of hearts, right? If I am selecting a green marble from a bag of multicolored marbles, The event is that I selected a green marble from the bag. So an event is just basically a desired outcome when something happens, right? That's what I mean by an event. So that means that we could rewrite this formula, right? So that means that the probability formula now can be written in a simpler way, right? Or it might not be simpler, but it's another way we could write it. So the probability of an event, E, is going to be the number of elements in the event, okay? The number of elements in the event divided by the number of elements in the sample space.
Excuse me, Mr. T, I have a question.
And that is, this is,
Are we doing after?
say it again?
What subject are we doing after this?
We are doing health science and general science. All right, health science and general science.
Thank you.
Yeah. And so, quick recap. So this formula is a formula that we could use, right? Instead of saying the number of favorable outcomes divided by the number of possible outcomes, what that means is that's going to be the number of elements in the event divided by the number of elements in the sample space. And this is a formula that we could use for the probability. Okay? Does that make sense to you all? Or no?
Pardon me, Mr. Petit. I just came back. I wanted to know what I missed.
I just was explaining what event and sample space is. We said that the sample space is going to be the total number of all possible outcomes, right? And the event is going to be when something happens. So if I select a green marble from a set of multi-colored marbles, when I select heads over tails, when I select peanut butter, sorry, when I select an orange out of a bag of other fruits, that's an event, right? So we say that another way we could write the probability formula is that you can say the probability of an event E occurring is going to be the number of times that event occurs divided by the number of elements in that sample space, or the number of elements in total. And that's the formula for our probability. All right, do we have this written down? Do we have this written down? Let me know if you have this written down.
Mr.
Yes,
I have
sir.
a probability for you.
Again, do you have this written down? All right, once you finish off this written down, take a picture of it and send it to me via WhatsApp. Again, take a picture of this and send it to me via WhatsApp. Again, take a picture of your work and send it to me via WhatsApp. Okay. We're gonna move on to health science now.
Right, done, send my thing.
All right, good. How many persons have already sent in their work?
Good night.
Good night. All right.
Sorry, Mr. Petit.
Okay, so let's go ahead and
Mr. Petit, sorry. Did you see my message yesterday, please?
no, I didn't. I'll check it.
Thank you very much.
No problem. Okay, let's go ahead and all right, let's go ahead and move on to what? Health science? All right.
That's what, Mr. Petit.
Uh-huh.
I have a probability with you.
Go ahead.
What do you think the probability is of you beating me in the game of Uno?
Oh, 0. I don't know how to play that.
Even if you didn't know the place, it's supposed to be 0.
All right, let's go ahead and do this. So we are on health science. Let's go with health science. The last thing we was doing was what? The heart and blood vessels and stuff like that. So let's go ahead and head up. My name is Mr. Petit.
Good night.
Good night.
Thank
Today is no problem. Today is Tuesday the 11th of March, 2025. Subject is, of course, health science. Okay. All right, health science. Okay, and the topic is, the last thing we did in health science, what did we do, class? The last thing. We talked about the what? No, I can't remember. Last thing we did in health science. Antoine, can you remember?
I don't do health science, so I don't know.
Blood vessels.
Say it again, the
Blood vessels.
blood vessels. What did we learn about the blood vessels? Or which 3 blood vessels we talked about? Let's start with that. Which 3 blood vessels we talked about? Come on, class. Which
Capillaries.
capillaries? What else? Capillaries.
Arteries.
Arteries. Yes, arteries.
And veins.
And veins. Very good. Out of those 3, which one is the smallest? What is the smallest?
The capillaries.
The capillaries.
The capillaries. Very good. And out of the 3, which one has thick muscular walls?
The
arteries.
Arteries.
Very good. Which one carries the blood away from the heart? Away from the heart.
Arteries.
Arteries. Very good. Which one has valves? Which one has
Veins.
valves? The veins. What is the purpose of valves?
To prevent blood from flowing backwards.
Very good. To prevent the backflow of blood. Very good. Next. Which one usually deals with blood in high pressure? In high pressure.
The arteries.
The arteries. Very good. Which one usually deals with blood? Which one? What are the 3? Whether it's veins, capillaries, or blood vessels? Which one carries blood? Which one carries deoxygenated blood? Deoxygenated blood. Which one carries deoxygenated blood?
Veins.
Veins. Very good. And which one carries oxygenated blood?
Arteries.
Arteries. Very good. The topic we're going to be looking at today is going to be the respiratory system. And that deals with obviously the lungs, the bronchi, bronchioles, yes.
Which one you said have the valves?
Veins.
Okay, thank you.
Good. So we're dealing with the respiratory system at this point. So I'm gonna be doing it. Let me open your mic. Respiratory system. So let's go ahead and write down these notes. So this system, what's the function of the respiratory system? So this system
to exchange oxygen and carbon dioxide.
Very good. It's responsible for bringing in oxygen, gas needed by the body for respiration. Now, respiration is a process by which If I ask you what is respiration, what would you tell me?
The intake.
Say it again. What is respiration?
It's the process of release energy.
Releasing energy. Who said that?
Dressler.
Dressler. Okay, that's very close. So some people confuse respiration with breathing. I mean, people might think respiration just when you breathe in, right? That's respiration, right? But that's not respiration. That's breathing, right? Respiration is a specific process which has a specific formula, right? And it's a process by which oxygen gas, right, and glucose are combined to release what? Energy. Okay, so this is very important. So respiration is when we it's a process, right? Respiration is a process by which oxygen gas and glucose are combined to release energy. Okay, that is basically respiration. So we combine in oxygen and glucose. By the way, what is glucose? Glucose is what? It's another word for glucose.
Sugar.
Sugar, very good. So when we combine oxygen, right, and glucose, then using that process of respiration, we are gonna be able to release energy. So it's how we get energy, right? So that's that. Let me go ahead and move this. Respiration is the process by which oxygen gas and glucose are combined to release energy. That occurs in where does respiration occur?
In the lungs.
In the lungs.
In the alveoli.
In the alveoli.
In the lungs.
No. Where in the
In
cell
the
then?
blood.
Where in the cell?
In the nucleus.
No, definitely not. Where in the cell?
In the mitochondria.
Who said that?
Ronaldo.
Ronaldo, very good. Very good. Where in the cell? It's definitely going to be in the mitochondria. So that occurs in the mitochondria. Mitochondria occurs in the mitochondria of cells. This process can be represented in the equation shown below. So I'm going to show you two equations, right? We're going to have the word equation, right? Word equation. And then we're going to have what we call the chemical equation. So you have the word equation and you have the chemical equation, okay? The word equation and the chemical equation. So the word equation is that glucose plus oxygen gives us arrow gives us glucose plus oxygen gives us what? What do we need? What we trying to form? What is trying to be released? What is trying to be? What's trying to be released? Energy. Very good. Energy. 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 Okay. Energy. And then you have byproducts. Just gonna be carbon dioxide.
Carbon dioxide.
Carbon dioxide. And what else? What are other stuff that is released as well? Start with W.
Water.
Water. Very good. And water. This is the formula for respiration. This is what respiration is. Respiration is the process by which glucose and oxygen is combined to give us what? To give us what?
Energy.
To give us energy. So basically respiration is the energy making machine. So think about that like that. Respiration is the energy making machine. It's going to be the way by which we get oxygen and glucose to combine together so we can get energy. So basically, think of it like this. Oxygen is the key, right? Oxygen is the key that unlocks, right? That unlocks it. And so what we need glucose and oxygen to combine. Once we combine that together inside of the cell, in the mitochondria, we're going to get energy, right? It's the main thing, ATP, which is this form of energy that the cells need. And then glucose is just a byproduct. Water is just a byproduct. We don't really care about them, although we do, but that's not the main purpose of this process. The main purpose is to get energy. That's the main purpose. So let me clear our drawings with this one. So that. Okay, so now we need the erase clear our drawings. Now we need the chemical equation. I don't know if you're familiar with the chemical equation, but the chemical equation.
Mr. Petit.
Uh-huh.
Why is energy in all caps?
Because that's the main product. Okay. Equation. So chemical equation. Here we have so we have what is the chemical formula for glucose? Does anyone know? The chemical formula for glucose. Boy, if y'all know that.
Cl plus something.
Oh boy. The chemical formula for glucose is C6.
See, I was close.
H12. O6. C6H12O6. Say that fast. C6H12O6. Can you say that fast enough? Can I say that?
C6H12O6.
Faster.
C6H12O6. C6H12O6.
C6H12O6.
She said
C6H12O6.
What is that? That's the chemical formula for what?
Glucose.
Glucose. Very good, for glucose. The glucose. C6H12O6. How many carbon atoms do we have? 6 carbon atoms.
6.
How many hydrogen atoms?
Hydrogen. 12.
12. How many oxygen atoms?
6.
6. Very good. And then so then we need oxygen. What's the chemical formula for chemical? Yeah, what's the chemical formula for oxygen?
O2.
O2, very good. O2.
O2.
O2, very good. O2. It's gonna be O2. 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 So O2. Okay. O2. And then what else? So C6H12O6 O2. What else? Then we need what? Energy. We can call energy ATP. Let me just put energy. right? Okay, and then what's the chemical formula for carbon dioxide? What's the chemical formula for carbon dioxide?
CO2.
CO2, very good. CO2. CO2. Insert CO2. So CO2 plus water. What's water? Water is what?
H2O.
H2O. Water is H2O. H2O. Okay. And there we go. And so that's our chemical equation. So it's going to be glucose plus oxygen gives us energy, carbon dioxide, and water. That's basically the formula. We call this on the left-hand side, we call this the reactants, and on the right-hand side, we call them the products. So reactants and then products, okay? All right. All right, next. Let's go ahead and move on from this. So this is respiration. If I do this like that, this is the count. Okay, so when you breathe in the air, right? What do you think is the most abundant gas in the atmosphere?
Carbon dioxide.
Nitrogen.
No, not carbon dioxide.
Nitrogen.
Nitrogen. Anyone else? What is the most abundant gas in the atmosphere?
Oxygen.
Oxygen.
Yeah.
Okay. Anyone else? What is the most abundant gas in the atmosphere that y'all think it is?
Oxygen.
Oxygen. A lot of oxygen.
Nitrogen.
Nitrogen. Really? You think it's nitrogen?
Yes, sir.
Yes.
Really? So what are we gonna do with nitrogen? Why do you think nitrogen is the most abundant? Why would it even be nitrogen? What are we gonna do with nitrogen? No one is answering. So let me show you all the chart, the official chart.
Has a
Right?
lot of energy.
It has a lot of energy. Okay, so the official chart that shows the composition of all the gases in the air. Okay. So in first place, we have none other than the one that's in red. That's gonna be what?
Nitrogen.
Nitrogen. So back to my question. What is the most abundant gas in the atmosphere?
Nitrogen.
It's
Nitrogen.
It's nitrogen, very good. It's like Chai and Alea said, right? Nitrogen. Then the next most abundant gas is going to be what?
Oxygen.
Oxygen is the most, coming at a staggering 21%. All right, and then we have the little other gases, argon, carbon dioxide, stuff like that. They are less than 1% of the atmospheric gas. And then water vapor is up to 2%. So basically, we're dealing with majority of nitrogen and oxygen. Oxygen, of course, is needed for respiration in order for us to make energy. Okay, and nitrogen has a lot of purposes that helps everything work properly. Okay, so we have the nitrogen cycle and all that. Okay, so the most abundant gas is in the atmosphere is nitrogen. So I mean, yeah, it's nitrogen, but when we breathe in, we call that inhaled air. When we breathe in that air is gonna have more oxygen. But when we breathe it out, it's going to have less oxygen and more carbon dioxide because we are breathing out carbon dioxide. So before before oxygen can be, oh, sorry, let me put this here. Before, so I guess this is cemented here. So before let's put this up here. So before, let me just move this out. Yeah, before oxygen can be extracted from the air, air must enter the body. Air is a mixture of gases, right? Air is a mixture of gases composed of how much percentage of oxygen do we have?
21.
21%.
Very good, 21% oxygen. 78% nitrogen. See how many carbon dioxide? 0. What? 0.03% of what?
Nobody's touching your hamburgers.
0.03%.
Can I have one hamburger?
I know, right? 0.03 carbon dioxide.
Okay, y'all can have that. Sorry.
0.03 carbon dioxide. And what else? And 0.97 % of what? Other gases. When air is exhaled, it will have less what? Less what? Exhaled air.
Oxygen.
Less what? Less oxygen. And more, but more what? But more carbon dioxide. Why is that?
Because the body needs the oxygen, so it extracts it out.
Yeah, this is because during breathing, carbon dioxide, we could say during exhalation, carbon dioxide is released. Okay, the body releases carbon dioxide because the body don't need carbon dioxide. Carbon dioxide is considered waste for the body. But we do need oxygen. Okay. All right.
Excuse me, Mr. Pradeep.
Go ahead.
What you said about nitrogen, you said nitrogen is the most something.
Abundant gas in the atmosphere or in the air. Okay, go ahead, Dinaj. Dinaj, can you hear me?
Yes, sir.
You still giving out hamburgers?
That wasn't me.
That wasn't you? All
So
right.
tell him I'd send one to Berry Island, please.
I know, right? Go ahead, Dinaj, read the system.
The system is responsible for bringing oxygen in. Hold on. Can I mute my phone? This system is responsible for bringing oxygen gas needed by the body for respiration. Respiration is a process by which oxygen gas and glucose are combined to release energy that occurs in the mitochondria of cells. This process can be represented in the equation shown below. Word equation, glucose plus oxygen equals energy plus carbon dioxide plus water. Chemical equation C6H12O6 plus O2 equals energy plus CO2 plus HO2. That's it.
Before?
Before oxygen can be extracted from the air must enter the body. Air is a mixture of gases composed of 21 oxygen, 78% nitrogen, 0.03 carbon dioxide, and 0.97 other gases. When air is exhaled, it will have less oxygen but more carbon dioxide. This is because during exhalation, carbon dioxide is released.
Very good. Thank you. All right, are we done with this? Let me know, please, if you're done. Let me know if you're finished with this.
Mr. Petit, what you said?
Are we done with this?
Last 5 words.
Okay. The rest of us, are we done with this? Riley, are you finished with this? Where's Riley?
I'm finished.
Okay.
Yes, sir.
And
Done.
Crimson, are you finished with this? Where's Crimson? Crimson, can you hear me? Crimson, can you hear me? Where's Crimson? Can't hear from Crimson. Nathan, are you done with this? Where's Nathan? Nathan, can you hear me? Can't hear from Nathan. And Danielle
Hello?
Johnson. Where's Nathan?
Hello?
Yes, Nathan, are you finished?
Yes, sir.
Okay, have you sent in the work?
No, sir.
Okay. All right, let's go ahead and move on to general science. And then we're gonna close this thing out. So last thing we was doing in general science is we talking about good friction and bad friction.
Mr. Petit,
Yes.
if you're only doing general science, you have to stay.
Who's this speaking?
Tarika,
Have you already sent in your notes, Tarika?
I'm gonna send it right now.
Yeah, send in your notes, and then if you're not doing general science, you can leave.
Okay.
Did you see my question?
No, I haven't seen it. Okay, good. So what we're gonna be looking at now is we're gonna be looking at a very good topic. I couldn't wait to get to this one. Couldn't wait. This is it's gonna be, subject is general science. General science. Okay, so all right, so general science, let's go. So we're gonna be looking at machines. Machines. Anyone ever learned about machines before in their class or at school or something like that? You all learned about machines?
I learned about simple machines.
Okay. That's okay. So a machine doesn't only have to be simple, right? See, a machine doesn't only have to be simple. It could be what?
Complex.
Complex. Very good. It could be complex. It doesn't have to be simple.
Locomotive.
Right? So you have a simple machine and you have a complex machine. Okay. So let's go ahead and do this. So we have number one. So a machine is a device, right? A machine is a device that makes it easier to what?
Perform work.
Someone say that. Say it again. That makes it easier to
Perform work.
to do work. Very good. To do work. To do work. And as we said, work is going to be force multiplied by what? Force multiplied by what? What is work? Work is force multiplied by distance. Very good. All right. So distance in the direction of the force. So the task, right? So the task may otherwise be very difficult, or impossible to perform. So some of these simple machines, or machines in general, are so useful because if it wasn't for them, then doing that same activity would be very, very difficult. Okay. So it allows us to use a small force, right? But to overcome a larger force. Okay. So that's how we know it's a machine. So when we put a little bit of force, but yet we have we are able to overcome a larger force. Okay. So it enables us, so that's what we call it, because you have a leverage, right? So it enables us to use a small force called what? What is this? What is a force that is placed onto an object or onto a machine called? What we call that?
Pressure.
Not pressure. Start with E. Start with E.
Effort.
Say it again.
Effort.
Effort. Very good. Effort. Effort. All right. And so we have, it's called effort. So it enables us to use a small force called effort. All right, called effort. To overcome a larger force. Overcome, when we say overcome, to move a larger force. Called what? So the amount that would be put in is called the effort, right? We call that the effort, right? But the force that must be overcome is what? Is the load. Y'all ever heard of that? The load. Okay. The load. Okay. And so go ahead, Aiden. Aiden, can you hear me? Where's Aiden? Aiden, can you hear me? Can I from Aiden? Shavarian, can you hear me? Where's Shavarian? Shavarian? I can't hear from Shavarian. Shavarian, can you hear me? Have you sent in the notices yet for health science?
No, sir.
What are you waiting on?
I do it now.
So send in your notes for health science. D'Angelo Smith, where's D'Angelo Smith? D'Angelo, can you hear me? Where's D'Angelo? Jasmine Rose, go ahead, Jasmine, read this, some people is.
A machine is a device that makes it easier to do work. The task may otherwise be very difficult or impossible to perform. It enables us to use a small force called effort to overcome or move a larger force called load.
Very good. And Chloe, can you read this to me? Chloe.
Yes, sir.
Chloe, have you sent in your work as yet?
No, sir. My mom ain't home, so I could send a note to your phone.
Have you been writing them down?
Yes, sir.
Okay, good. Go ahead and read this to me, please.
Which line? The second one?
No, just a paragraph.
A machine is a device that make it easier to do work. The task may otherwise be very difficult or impossible to perform. It enables us to use a small force called effort to move a larger force called the load.
Very good. Very good. All right, next. So let's talk about, okay, so for this reason, machines are sometimes called force multipliers. Force multipliers. Okay. Now we have different types of machines, right? The first type is going to be what we call the simple machines. Simple machines. What type of simple machines do y'all know? Simple machines.
Pulleys.
Pulleys.
And levers.
Levers.
I mean levers.
Yes. What else? What other type of simple machines y'all know?
Inclined plane.
Inclined plane, very good.
Wedge.
A wedge, yes. Do y'all know that a bike is a simple machine? Well, not really the bike, but the wheel, right? The wheel, an axle.
A
Simple
seesaw.
machine. Say it again.
A seesaw.
A seesaw, very good. Very good. That's a lever or lever. So simple machines, right? Simple machines. Y'all ever learn about simple machines? Are machines
In primary school.
that do not need motors. They don't need motors. Okay. Okay, so some machines use a combination of two or more simple machines called compound machines. Right. Now, when we talk about compound machines, we know that these machines, they need a what? Compound machines need what?
A motor.
They need a motor. Very compound machines are machines that need motors. What are some examples of compound machines that we could think of? Examples
Engine?
of engine? No, examples of compound machines. Examples
An
include
electric bike.
electric
Or
bike.
scooter.
How about cars? I'm surprised y'all didn't say cars.
Oh, I thought these were small stuff.
Yeah. Someone say washing machine. Anyone would like to get a Tesla when they grow up? A Tesla?
Yes, sir.
No, sir.
No?
I want one.
You don't want?
Well, my family has a business as a car rental, so now I going with that Toyota.
Toyota. Okay. I was
It's
not
the D. When I
not
stop my
expecting.
car, I will feel it shake.
You want to feel it shake?
Sound like something wrong with that.
I know, right? How about a Cybertruck? Cybertruck.
I want a Cybertruck.
I don't like them. They look ugly.
I don't even know what that is.
You don't know a Cybertruck? Oh,
It's a
It's a gray car that looks like an alien ship.
you know, right? How about Mercedes?
Yes, sir.
Yes, affirmative.
Yes, I
Yes.
want a personalized Mercedes with
So
light blue lights
Do you give
inside.
away Ford trucks by any chance?
let's say Ford trucks. So you have the cars and you have the trucks, right? Those are examples of what type of machines?
Compound.
Compound machines, trucks, even power tools, right? Power
Like the
tools.
drill and stuff like that.
Anyone there know how to sew? Right?
Yes, sir.
Yeah.
Yes.
What's the
Yes.
question? Drill.
Sewing machines, right? And then you have
Mhm.
everyone in there should have a refrigerator, right?
Yes, sir.
Okay, hopefully.
Yes, sir.
And refrigerators. Okay, those are all compound machines. Okay. So go ahead, Liliana. Where's Liliana?
Yes, sir.
Are you writing this down?
Yes, sir.
Have you sent me the notes as yet?
Not yet.
You have to send in the notes. I mean the note. Have you sent in any of the notes yet?
I sent in math and health science.
Okay, good. Read the simple machines and compound machines, please.
Simple machines are machines that do not need motors. Some machines use combinations of two or more special machines called compound machines. Compound machines are machines that need motors. Example include cars, trucks, power tools, sewing machines, and refrigerators.
Okay, very good. And Megan Penniman, read what we have for sewing machine and compound machine. Megan,
Yes.
Megan, where's Megan? Where's Megan?
Yes.
Read what we have for simple machines and compound machines, please.
Simple machines are machines that do not need motors. Some machines use a combination of two or more simple machines called compound machines. Compound machines are machines that need motors. Examples include cars, trucks, power tools, sewing machines, and refrigerators.
Very good. All right, so next. So let's go ahead and list off our simple machines. Let's go ahead and do that. So for that one, I want to do a table. Then we're gonna list off the simple machines on them. All right, so we have insert. It's gonna be there. And then like this. Okay, good. So we have simple machines. We have examples. So simple machines are gonna be lever or lever. What are some examples of a lever? It's gonna be what? I know I must have something, the seesaw.
No.
Wheelbarrow.
Yeah.
Yeah, wheelbarrow. Then we have stapler. It's an example of levers. Okay. And then we have after lever you have inclined planes. What do I mean by inclined plane?
Like a slope.
Like a slope, like a ramp, right? A ramp. Would they use for persons who have disabilities? And you have the stairwell. Okay, and then another example of a simple machine would be a pulley, right? Pulleys. So you're talking about
Well,
A flagpole. That's an example of a pulley. Flagpole.
Just supposed to say.
Say it again.
I was just about to say that.
You're just gonna say a flagpole. That's good. What else? Flagpole. What else?
a well,
Say it again.
water well,
Water well. Okay. How about like a curtain rod? Curtain rod.
Yes.
Hoisting sail. No, when you hoisting the sail and you do the ropes,
Blinds.
right?
The blinds on your window.
You have the there's different types of pulleys. You have the fixed pulley, movable pulley, and block and tackle pulley. Okay. And then you have the wheel and axle. Wheel and axle. That's gonna be like steering wheel.
doorknobs,
All right. Have you ever heard of the Ferris wheel? Right.
Yes, sir. I
Mhm.
want to go on so bad.
Ferris wheel. Say it again.
I said I want to go on so bad.
You ain't afraid of heights?
I am.
You are.
I don't want to
All
go.
I scared dream about is falling off of something, off of the thing. I still terrified. I still traumatized.
You fall? You fell before?
No, I haven't fell off of the building. I'm saying that in my dreams,
Oh,
I have fall before. I
oh,
still terrified from it.
wow. From a dream. That's
Mr.
crazy.
Petit,
It would mean
that's supposed
nothing.
to say fixed with an ED, like it fixed,
Yes, you could put fixed. Fixed, movable.
and that's just the types you saying.
That's just the types, yeah. So fixed
Thank
pulley. Let me just put it there. Fixed pulley.
Mr. Petit,
Movable pulley. Yes.
you ever one of them dreams, right? And like you falling, and as soon as like you about to hit the ground, you wake up.
Ah, I know what you're talking about. That's
That's
happened to people
exactly what happened to me.
Yeah.
below. Like before you die, you wake up. It's like,
You know,
alright,
what an old person tell me? Say
what?
that's when the angel carrying you up and they drop you.
Anyway, lever, seesaw. Every time you make reference to old people, how many old people do you live with?
I only know like 2 old people, my Grammy and my grandpa. Yeah,
You live with them?
no, sir.
Okay. They're alive?
Yes, sir.
That's really cool. All right, so
My
what are
Grammy
some?
down here about 90 years old.
Wow.
Almost
Wow.
100. Everybody keep praying. Almost 100.
Wow. All right. Okay, so I need y'all to give me some examples of simple machines. Some examples of simple machines. Some examples of simple machines.
Wheel and wait,
Lever. Seesaw.
screw,
Say it again. Screw. What else?
axe blade,
Wait, axe blade. Very good. What else?
lever,
Very good. Lever.
A bike.
Seesaw.
What else?
Flagpole. Okay.
Flagpole. Very good. I want the types though. I want the types.
Pulley.
Pulley. Very good.
wedge,
Inclined plane.
Inclined plane. Very good.
wedge,
Wedge. Very good. What else?
Mr. T,
Mm-hmm.
Wheel and
you
axle.
don't answer my question yet.
What? What
In the
question?
chat,
Oh, I saw it. Daniel Johnson, where's Daniel?
We're supposed to send this in?
Yes, you have to send this in once you finish. All right. Take a picture of this and send it to me via WhatsApp again. All right, and Danaj Moss, where's Danaj?
Yes, sir.
Okay. Do you already send in your work, Danaj?
I'm about to send it right now. I
Okay.
just sent it to you.
Okay, good. And Crimson Clark? Crimson? Where's Crimson? Riley, where's Riley? Riley, can you hear me?
Yes, sir.
You already sent in your work?
I'm sending it right now.
Okay. And Ethan Adley, where's Ethan Adley?
Yes, sir.
Okay. Wow. All right, you already sent in your work?
Yes, sir.
Okay. Good. The rest of us, have we sent in the work? Let me know, please.
No, sorry about to finish.
Yes, sir.
Good.
Yes, sir.
About to finish.
Okay, good. All right, and all right, are we done with this? Let me know, please. You are done with this?
No, sir.
Okay, good. All right, once you're finished, then yes, once you finish, you can leave once you finish. Send in the work.
Good night, Mr. Petit.
Good night.
Good night. Good night.
Good night.
Good night.
Good night.
Good night.
Good night.
Good night.
Good night. Good night.
Good night.
See you tomorrow by God's grace.
Yes, take care.
Mr. Petit.
Good night.